Motion in a plane. Now we are going to discuss about that motion in a plane. When a body is moving between in the plane, then the physical quantities means whenever the physical quantities are mainly thing are it can be classified into two types. What are meant by the physical quantities? Physical quantities are the quantities which can be measurable is called as physical quantities. That physical quantities can be classified into the two types, that those are scalars and vectors. The physical quantities means the quantities which can be measurable is called as physical quantities, and the physical quantities can be classified into two types, those are scalars and vectors. In that case, what is meant by the scalars? Means here scalars means the physical quantities which are having only magnitude but no direction. The physical quantities are having only magnitude but no direction, or that physical quantities are called scalars. Means for example, length is a scalar quantity that can be measured in a 3 or 4 kilometers and meters and also centimeters, which can be classified into this. Means we can measure but without any direction, without any specifically direction. In any direction, if we measure that the same quantity, same magnitude, we can get that. So means here the length does not depends on the direction. They means that there is no any specific direction, only there is a some magnitude is there. And also time is also length, time, area, volume, density, temperature, mass, work and energy. Here some of the physical quantities having the direction is also can be considered as scalars, like electric current, surface tension. Because of here the scalars means which is having the direction, but they do not obey the laws of vectorization. So that's why here the electric current can be considered as a scalar quantity. Electric current is having the direction and magnitude, but does not obey the laws of vector addition. So that's why here we can say that the electric current is having the magnitude. In case of having the magnitude also, we can say that the electric current is a scalar quantity. And as well as surface tension. Surface tension means always the tension, stress is acting perpendicular, means tangential to the surface of the water. Always acting surface unified, it's a specified direction, it is having the specified direction. So that's why some of the specified unified directions can be considered as also. We can consider that in any case of is always surface tension means the tangential always acting tangentially on the surface of the liquid, whatever the liquid we are taking there. So that's why here surface tension also can be considered as it's a scalar quantity. Whatever the magnitude, what is the number is given by the value, then this has no sense of direction. So that's why here the number indicates the magnitude of scalar quantity, and is inversely proportional to the unit. Whatever the unit chosen, that is inversely proportional to the unit chosen. And as well as here some of the examples given, that is a length, time, area, volume, density, temperature, mass, work and energy, as well as some surface tension and electric current. Here those are the examples are given. They give the direct values which can be measured directly. We can get the magnitude without any direction. So that's why these are called as scalar quantities. And as well as here this unit has no compulsion to represent the scalar quantity, means must be, it doesn't require any, definitely it has to be, it has no right to be, unit is not compulsory to represent the scalar quantity, like a refractive index, specific gravity, those are doesn't have any units. So but in case of this those are also having that scale, those are also scalars. Means unit is not compulsion to represent the scalar quantity. Without unit also we can specify that's a scalar. Here that the specific gravity and refractive index also we can be considered as a scalar quantities. And also the scalar can be maybe negative also. If in case of work is a scalar quantity, we know that positive work is there, negative work is there, zero work is there. Means here the scalar may be negative. Scalar may be negative. This is about scalars. This is about scalars. In further units, we will discuss about scalars deeply. Now, the next one is vectors. Vectors means here the physical quantities having both magnitude and direction. Magnitude and direction are called and it has to obey the laws of vector addition. The physical quantities must obey the laws of vector addition. If in case of the physical quantities having the magnitude and direction, if they don't obey the laws of vector addition, that cannot be considered as a vectors. So here it is that the physical quantities must obey the laws of vector addition, and they have both only both magnitude and direction. Those physical quantities are called vectors. Here, as a mathematical object line, we can say consider that is a directed line segment. Means whenever the physical quantity, for example, here velocity is there. If in case of it's a vector quantity, then this type of line which can be considered it's a vector. Either in textbooks the vector quantities can be given in bold letters. In some of the textbooks the vectors can be considered as given as a bold letters. So this is all the vectors. It can be represented, the directed line segment will be like this, directed line segment, because of its velocity is having some of direction. Because of we are measuring that the displacement, velocity, axle. Displacement means the shortest path, the shortest line drawn came from initial point to the final point. Means initially there is some specific direction is there. We are drawing the shortest path. Then only we can get the value for displacement. So here it is that the displacement is a vector quantity. Means in case of the body is moving, the shortest path we can draw. This is initial consider, this is a final, then shortest path in a specified direction, then only we can get the value for displacement, as well as velocity also, as acceleration, linear momentum, force, angular displacement, angular velocity, angular acceleration, torque. These are the total values having that. All quantities having both magnitude and direction need not to be the vectors. All the physical quantities which are having the magnitude and direction, they do not need to be vectors, because earlier I told you there's electric current, like electric current is having this some of the directions. Means if in case of I1 current is moving in this direction and I2 current is moving in this direction, then it's making an angle theta. It doesn't depend on the current does not depend on its direction. It is having different values in different directions also. It gives the measures. So that's why we can say that it does not depend on its direction, the angle between them. So here we can say that the electric current is having the magnitude and even the magnitude and direction also, but that cannot be considered as a vector. That's a scalar. And velocity of light also. In velocity of light also, that does not depend on the direction. So here it is that even though the physical quantities are having magnitude and direction also, cannot be considered as a vectors. If in case of the physical quantities, if the physical quantities are having different values, means different magnitudes in whenever in different directions in medium, means the physical quantities which will have different values along different directions are called tensors. Tensors means physical quantities which will have different values along different directions called tensor quantities. Here the example for this, that is a pressure, like stress, moment of inertia. Means here some of the moment of inertia means it does not depend on its direction. The moment of inertia will be different whenever we compress a ball. By applying the stress, then in some different areas which is having the different value, In different directions, different magnitude is there. So that's why we can say that it is having the magnitude and direction, but it is having in different magnitudes in different directions. So that's why we can say that the stress is a tensor quantity, and moment of inertia is also there. It is having the different values in different directions. So that's why we can say that the stress and moment of inertia can be considered as a tensors. Those are the physical quantities are having different values, means different magnitude values in different directions. It have. So that's why here stress, whenever we compress a body, then whenever we compress it at different parts, it has different directions on your body, different directions, it has different magnitudes, different values are there. So that's why we can be considered as those are stress and moment of inertia can be considered tensors, and as well as it can never be negative. Tensor quantities cannot be never be negative. So that's why here it never be negative. These are about the classification of physical quantities. Once again, physical quantities called the measurable quantities are called as physical quantities that can be classified by the characteristics, their properties, which is having the sum of the characteristics parameters. Those are scalars and vectors. In the case of scalars, the physical quantities which are having only magnitude but no direction are called scalar quantities. And for the example are the length, mass, work, and as well as time, like this. Temperature, surface tension, electric current, those are there. And also all the physical quantities which are scalars, somehow physical quantities are having magnitude and direction also can be considered as a scalars, even though they are having the different values in different directions. Even though that magnitude does not depend on the direction, so that's why that can be considered as a scalar quantities. And a scalar can be negative. So next one is vectors. Physical quantities are having both magnitude and directions are called and it has to obey the laws of vector addition are called here the vectors. A physical quantities which are having both the magnitude and direction and to must obey the laws of vector addition are called vectors. Here we can give the mathematical object. Mathematical object is different. A directed line segment. A directed line segment is called also, is considered as a definition for the vectors in mathematical form. So the examples are displacement, velocity, acceleration, linear momentum, force, angular displacement, angular velocity, angular acceleration, torque, etc. All the quantities are having the magnitude and direction need not to be the vectors. For example, here electric current and velocity of light. Electric current does not depend on the direction of the currents. So that's why we can consider that can be considered as a scalar quantity. The physical quantities which are having different magnitudes in different directions are called tensors, like stress and moment of inertia. And tensors cannot be negative. This is about vector, scalar and tensors.